Welcome to Networks Professionals.
Welcome to this explainer. Today, we're diving into a technology that is quite literally democratizing the future: time series forecasting. If you've ever wondered how top organizations seem to just anticipate the unknown and stay 3 steps ahead using modern AI tools, well, you're in exactly the right place. So, can AI predict your next inventory shortage? I know it sounds a little bit like science fiction, right? But think about the real-world unpredictability of business today. Supply chains break, consumer demands shift literally overnight, and suddenly, boom, shelves are empty. The stakes absolutely could not be higher. Being caught off guard by a shortage doesn't just mean a few lost sales, it means losing customer trust. But what if you didn't have to guess? What if the numbers you already have sitting right there in your database could whisper the exact day you're going to run out of stock? That is the sheer, undeniable power of forecasting. Okay, let's get into this. Section 1, predicting the future. Let's define exactly what we're talking about here. Time series forecasting AI is utilizing historical sequential data to identify underlying patterns, things like seasonality and trends, to predict future values. And I really want you to focus on that phrase, sequential data. This isn't just some random pile of numbers. It's data arranged in a very specific order over time. The AI acts kind of like a brilliant detective, combing through that sequence to find hidden rhythms. It spots the seasonal spikes, it notices the quiet long-term trends, and then it uses those historical fingerprints to tell us exactly what the future value will be. Now, when most of us hear about AI predicting the future, our minds usually jump to 2 things: the weather forecast and the stock market. And sure, those are classic examples, but the true power of this technology in 2026 goes way, way beyond that. We are talking about critical infrastructure here. These models are now actively used for predicting complex energy demand, ensuring the power literally stays on when usage spikes. They're predicting those massive inventory shortages we just talked about, and they're charting out incredibly intricate financial trajectories for major organizations. It's the heavy lifting of the modern economy.
All right, let's lift the hood and see the gears turning. Section 2, how the models work.
Now, what's really interesting here is how these models actually consume data. First, you have univariate models. These predict trends using just a single variable, like relying strictly on historical temperatures to guess tomorrow's weather. It's focused, it's straightforward. But multivariate models, that's where things get genuinely fascinating. This is where the AI layers multiple data streams together. So instead of just looking at temperatures, the model analyzes temperatures combined with wind speed and air pressure, all at the exact same time. By stacking these different variables, the model builds a much richer, highly accurate picture of what's about to happen.
And it's not just about the type of data, it's about the time horizon. The flexibility of this is absolutely thrilling. We're talking micro to macro. On the micro end, you've got ultra short-term predictions, like forecasting the electricity load for literally just the next hour. That requires rapid-fire processing. Then, moving to the middle, we can zoom out to predict quarterly revenue over the next 3 months. And finally, going completely macro, the exact same underlying principles handle long-term forecasting, projecting next year's annual revenue. So whether it's micro adjustments in a power grid or massive year-long financial planning, the AI scales to fit the exact window of time you need to see. But what is doing all that calculating? Well, it's actually a really elegant bridge between classic methods and the absolute cutting edge. On one side, we have classical statistical approaches, like ARIMA and PROFIT. These rely on beautifully logical math that has been extremely reliable for clear, structured data for years. But then we have modern deep learning, neural networks like LSTMs and transformers. These are built to handle massive, messy, complex datasets and find patterns that classical statistics might completely miss. The best forecasting today? It actually combines the rock-solid reliability of those classical approaches with the raw, untamed power of deep learning. Let's look at the software you'll actually use. Section 3, the 2026 AI Toolkit. Right now, the software landscape is brilliantly organized into 3 distinct buckets built for entirely different enterprise use cases. We've got zero-shot foundation models, the Python developer stack, and enterprise solutions. And honestly, figuring out which of these categories you belong in is the absolute key to successfully predicting your data. So let's break each one down. First up, zero-shot foundation models. We're talking about tools like Databricks TimeGPT and Salesforce MoiRai 2. What is incredible here is that they predict future data distributions natively. This is a massive breakthrough because they do it without complex training. You don't have to spend months feeding them highly specific labeled data to teach them how to work. They already understand the fundamental patterns of time series data right out of the box.
If you want native prediction capabilities really fast without building everything from the ground up, this is your magic wand. But what if you're part of a highly technical team? What if you need to roll up your sleeves and build something completely custom? That brings us to the Python developer stack. Here, libraries like Darts and NeuroForecast are the gold standard. They offer highly tuned versions of both the classical statistical models and the deep neural networks we discussed earlier. So if you have coders on staff who need absolute granular control over the algorithms to build a bespoke engine from scratch, this is exactly the route you take. And finally, we have enterprise solutions. Say your business needs the power of AI forecasting, but you really just want the software to do the heavy lifting for you. Platforms like DataRobot sit squarely in this space by automating the entire machine learning process. But honestly, the best part? They provide built-in interpretation features. The platform doesn't just spit out a number and leave you guessing, it actually explains why it made that prediction. And as we all know, that is the ultimate key to getting stakeholder trust. It's clarity and automation all wrapped up in one package. So let's bring it all together. Section 4, Finding Your Perfect Fit.
I want to leave you with a bit of a direct challenge. Look at your own projects right now and ask yourself two vital questions. First, what type of data are you actually trying to predict? Are you looking at finance trajectories, modeling retail sales to avoid those inventory shortages, or maybe predicting massive spikes in website traffic? And second, what is your team's true technical capability? Do you need user-friendly software that automates the machine learning? Or are you looking for those deep, customizable Python coding libraries? Really evaluating these exact needs is the only way you'll select the perfect tool for your use case. The future is out there waiting to be mapped. You just have to choose the right lens to see it. Thanks so much for joining me on this explainer, and keep learning.
Thanks for watching.